Hello students, how are you all? Welcome to the fourth part of electricity. First three parts, their links are there in the description box. You must check. In fourth part, we'll mainly discuss about the numericals based on combination of resistances. In our third part, we saw that the resistances can be connected as series and also in parallel. And today we'll see the numericals based on that. Already I have drawn a circuit here. You can see where resistances are connected in both series and parallel. We have to identify which resistances are connected in parallel and which are in series. And accordingly we'll apply the formula of series and parallel. Fine. So let us solve this sum. See, first of all, these two are in series and these two are in parallel. Fine. So which are in parallel? 7 and 7. So let us see what is the total resistance of this parallel combination. We know the formula of parallel, like 1 by x equal to 1 by 7 plus 1 by 7. Got it? Equal to LCM 7, 1 plus 1, 2 by 7. So 1 by x is 2 by 7. What is x? 7 by 2. How much? 3.5 ohm. So we got it 3.5 ohm. Now this 3.5, then this 5 and this 5. You can say that they are in series. You understood? Just imagine that, because we have calculated the whole parallel combination. What is that? 3.5. So just imagine that by combining these two, there is only one resistance, 3.5. Okay? This 3.5, 5 and 5 are in series. So what is the total resistance? R equal to 5 plus 5, 10 plus 3.5. That is 13.5 ohm. This is the total resistance. Now if I ask you to find the current passing through that circuit, to find that we'll use Ohm's law. According to Ohm's law, we have seen V equal to IR. We have to put all these values there, V equal to IR. So let us use that. V equal to IR. Now what is V? Potential difference, 10 volt. What is I? We do not know, we have to find it. What is R? 13.5. So what is I? 10 by 13.5. Got it? Now you have to calculate it. After calculation, whatever you are getting, that is I. So here I am writing I equal to 10 by 13.5 ampere. We know the unit of current is ampere. Understood this sum? We'll see another sum. See this circuit. 4 resistances are there. All are 5 ohm. Now all these are connected in this special way. You have to identify which are in series and which are in parallel. Let me help you. These two resistances are in series. How? This resistance is continuing with this resistance. So this and this are in series. That is 5 plus 5. So these two resistance, 5 plus 5, 10 ohm. So here we are getting 10 ohm. And here also you can see this 5 ohm and this 5 ohm. They are in series. See, continuation. Okay. So these two are in series, 10 ohm. Fine. And these two are in parallel. Because from where the wires are going to the battery, from here it's going to the battery, and from here it is going to the battery. So these two are in series, these two are in series, but these two are in parallel. So 10 ohm and 10 ohm are in parallel. Got it? So what is the total resistance? 1 by R equal to 1 by 10 plus 1 by 10. Solve it. Equal to 2 by 10 ohm. So R equal to 10 by 2, that is 5 ohm. So we are getting 5 ohm, the total resistance of this circuit. Fine. Let us go for another sum. Now see this circuit. In this circuit, few resistances are connected in series and few are in parallel. If you see, all these 6 ohm are in parallel, whereas all these 12 ohm are also in parallel, but this 8 ohm is in series with all. So first we have to calculate all this, the whole combination, then we'll calculate this combination, then we'll add all. Let us do it. So for this combination, 1 by R equal to 1 by 6 plus 1 by 6 plus 1 by 6. Correct? Since it is in parallel, so we know the formula parallel. Now, what is the LCM? 6. So 1 plus 1 plus 1, that is 3 by 6. Okay? So what is the resistance? 1 by R equal to 3 by 6. So R equal to 6 by 3. Understood? So what is the resistance? 2 ohm. 2 ohm. So we got it, 2 ohm. The total resistance, 2 ohm. Now we have to consider these two are also in parallel. So in the same way we will take out their resistance. What is their resistance? 1 by R equal to 1 by 12 plus 1 by 12. Okay? So 12, that is 2 by 12. So 1 by R equal to 2 by 12. So R equal to 12 by 2. R equal to 12 by 2. That is 6 ohm. Understood? So this is 2 ohm, this is 6 ohm, and this is 8 ohm. Now you just think in that way. By combining these three, one resistance, that is 2 ohm. By combining these two, one resistance, that is 6 ohm. So 2 ohm, 6 ohm and 8 ohm are in series. And we know that when resistances are in series, just simply add them to get the equivalent resistance. So what is the equivalent resistance? 2 plus 6, 8 plus 8, 16 ohm. Correct? 16 ohm is the equivalent resistance of this circuit. So R equal to 16 ohm. Total resistance of this circuit or equivalent resistance of this circuit. Now if I ask you, what is the amount of current passing through this circuit? Yes, to find current, again we'll use Ohm's law. According to Ohm's law, V equal to IR. Let us put all these values there. V equal to IR. So V equal to IR. What is V? Potential difference, 5 volt. What is I? We do not know. What is R? 16. 16. Got it? So I equal to 5 by 16. So what is the amount of current passing through this circuit? 5 by 16 ampere. 5 by 16 ampere. So we have seen how to find the total resistance, I mean equivalent resistance of a circuit, and from that how to find the amount of current passing through that circuit. I hope you understood. Thank you.